Next, we explore sine and cosine curves for angles from 90 to 180 degrees. Our approach will be as follows. First, we animate from 0 to 90 degrees both sine and cosine curves. Then, we will guess what the sine curve should be between 90 to 180 degrees. Then, we will check with animation if our guess holds. In the first part of the animation, we will see two curves generated as vertical and horizontal coordinates of our truck as it moves around the circular lake. The curve on the left in yellow is the sine curve from 0 to 90 degrees. The curve on the right in blue is the cosine curve from 0 to 90 degrees. In the second part of the animation, we will extend just the sine curve from 90 to 180 degrees. We saw how the sine curve in yellow is generated by the vertical coordinates of the truck as it moves. The sine curve started at 0 and rapidly increased in the first 30 degrees to 0.5. Then it slowly increased in the interval 30 to 60 degrees from 0.5 to about 0.86. And finally, from 60 to 90 degrees, it very gradually increased from about 0.86 to 1. Now, we will try and guess what the shape of the sine curve will be from 90 to 180 degrees. This curve has to start at 1 at 90 degrees, where the driver is perfectly north. And then the sine curve has to go to 0 at 180 degrees, where the driver is perfectly west. Have we seen any curve generated by motion along the circle that starts at 1 and goes to 0? Yes, the cosine curve between 0 to 90 started at 1 and went to 0. So we guess that the sine curve from 90 to 180 will look like the cosine curve from 0 to 90. Take a few minutes to rewind or pause to think about this. Let's animate the sine curve and check if it matches our guess. If our guess is right, the curves will overlay each other. Let's see. What we have seen is that the sine function between 90 to 180 degrees is the same as the cosine function between 0 to 90 degrees, or sine of 90 plus a equals cos of a.